College Algebra. We're back in lesson 4.5. Today we're going to focus on log equations. So the first one I have for you is 4 times the ln of x equals 36. When we have one logarithm in the problem, we're going to change it to an exponential. In order to do that, the natural log of x right here has to be by itself. So we're going to open up by dividing both sides by 4. Now, the natural log of x is a logarithm with base e. So if our base is e, our exponent is 9, and that's going to equal x. Now, I'm just going to leave my answer this way. That is an exact form of the answer. Again, if you're stuck there, remember natural log is log base e. And all I've done is I've taken my e to my power, and that equals x. I can do the same thing on part B. I only have one logarithm, so 3 to the exponent of 1 is x to the third minus 5. I'm going to add my 5 over, and I take the cube root, and I get x. One thing you're going to want to start doing with these is you're going to want to check your answers. Now, for these first two, that's not too crucial. What you want to do, though, is make sure that when you plug in your logarithm or plug in your value of x, whatever you're taking the log of has to stay positive. You can never take the log of anything negative. So if I'm checking this result, 2 cubed is 8, 8 minus 5 is 3, log base 3 of 3 is 1, which is what I should be getting back. Okay. On C, I can still see here that I have one logarithm. It's just that my argument is this big quadratic once I FOIL it out. So I'm still going to switch it to an exponential. Base of 3 raised to the third equals the argument for x plus 1 times x plus 1. Go ahead and FOIL it out. Okay, we're going to try to factor that. 4 times 26 is 104, so negative 104, and they have to add to 5. I believe that's positive 13 and negative 8. Okay, it appears as though we get 2 solutions. So what you're going to want to do next is you're going to want to plug in each solution and make sure that it checks. So when I put in negative 13 over 4 and I multiply that by 4, I get negative 13. And negative 13 over 4 plus 1 would be negative 9 over 4. I want to make sure that that comes out to be 3. So I'm going to have negative 12 times negative 9 over 4. Oops. and that's 27. And that's a true statement. 3 to the third is 27. Likewise, you're going to want to check and make sure the 2 checks. So if I put the 2 here, I'm going to have 2 times 4, 8 plus 1 is 9. And then 2 plus 1 here is 3. 9 times 3 is 27. Again, log base 3 of 27 is 3. So both of our answers do check. Okay. This problem, now we're getting into the ones where you have more than one logarithm in the problem. So what I want to do is get it down to one logarithm. So when there's more than one, I'm going to condense if possible. And remember that I can condense 2 logarithms by multiplying their arguments together. So I've multiplied the arguments together. Now I'm going to switch it to an exponential. Okay, let's see. Oh. Okay, that looks fine. All right, I don't think there's any factors that are going to work. So in some cases, you're going to have to do the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, let me grab my calculator here. So negative b plus or minus b squared minus 4ac. All right. 8 times 23 plus 1, 185. Okay. 185. What is that divided by 5? 5 and 37. That's just ugly. It's not going to come out to anything nice. But what I want to do is I want to make sure that right here and right here, that when I plug 1 plus the square root of 185 divided by 4 into n for x here and here, that those highlighted places stay positive. So what I'm going to do is I'm going to get 2 decimal values. So what I'm going to do is I'm going to take 1 plus the square root of 185. I'm going to divide that by 4. So that's roughly 3.65. And then I'm going to take 1 minus the square root of 185. Divide by 4. And that's also negative 3.15. Okay. If I put 3.65 in for x here and here, those highlighted parts stay positive. So I'm for sure that's going to work. If I put the negative amount in for x here and here, those are both coming up negative. So when you substitute back in, you go back to the original problem, and you want to make sure that what you're taking the log of stays positive. So the only one that's going to work for us is that positive root. Students miss these the most because they forget to check. Okay, moving on. This one has 3 logarithms. So what you want to do is try to condense 2 of them on one side first. So we'll condense again by multiplication. And I will throw out there real quick that a common mistake for kids is to take these equations and use what they think is a distributive property. And everything I just did there is illegal, so don't ever, ever, ever do that. There is no distributive property for logarithms. You have to use your properties. All right, what you have now is a problem with a log on each side. So once you have a log on each side, you're going to drop it. We're going to collect, let's see, like terms together and such. So those are going to add to 0. I can divide by 2. All right, and then we want to double check. We want to make sure the 2 and the -2 both check. You're plugging them in here, or here, or here. So the 2 going into each place keeps each argument positive, but the -2 fails in 2 out of the 3 locations, so we don't take it. The only answer we have is the 2. Okay, I'm going to pause my video here because I don't want to go over my 15 minutes, and then I'm going to start up again with the rest of these notes.